Was the last due date around?
Because I think I made the mistake of saying it was due one day, and I have it on Blackboard as due a different day. I'll take them both days. Because to be quite honest, when people were asking yesterday, I was trying to remember, and first thing I want to do is just make some, basically provide some information. Number one, on Blackboard, it said that the KSP lab was due today, but I mentioned in class and in lab that it's due on Friday, so I'm taking it either day. Number two, this week in class, we will be talking about Gibbs free energy. That conversation will extend through Monday of next week. I expect that we'll be able to complete Gibbs free energy in that short period of time. Number three, next Tuesday, come to lab expecting to do two things. The first hour, hour and a half of lab, I am going to be lecturing. The last bit of lab, we will be performing the lab. Now, by me being able to lecture next week in lab, if all goes well, we will finish all new material next Friday. If all goes well and we finish all new material next Friday, then we will not need to have a Zoom class the Monday of Thanksgiving week. Now, the other announcements are things that are coming up very soon. Number one, the lab that you performed this week will be due next Wednesday. I'll get my dates straight. The lab you performed this week will be due next Wednesday. The lab you perform next week will be due next Friday. And finally, the service learning final draft of the ACS version, the ramp worksheet, and my version are due next Friday. Now, for the ACS, for the service learning project, the way I want it to be handled is I want it to still be kept in your folder, but I want you to signify what is the final version by putting the word final in the name of the draft, the name of the document, so that I know what the final version is. But that way you don't have to print it off and turn it in. It can be turned in just in your Google folder. But make sure you label it as the final version. The last thing I wanted to mention, I was supposed to take a vote on Monday and forgot the vote. And that is whether or not the Tuesday after Thanksgiving break, we meet in lab to perform the demos. It will not impact your grade if there is no demo day. It will not impact your grade if there are no videos or photographs. Basically, instead of the service learning project being out of 100 points, it'll be out of 80 points. So last Friday or last Wednesday, I told you to think about what your preference is. Today we vote and majority wins. So all of those that would like to meet on the Tuesday after Thanksgiving break for the demo day, raise your hand. Well, I guess we're not having a demo day. Hey, you made my life easier too. But I promised you I would ask, so I was making sure that I asked. Okay. That means we will not have lab of any sort after next Tuesday. Next Tuesday is the last lab of the semester. Okay, so I've kind of given you an overview of where we're headed and what I'm planning to do. I will say all new material, there are the flipped classroom videos are already posted. I've already posted next week's folder. I did that this morning, and in addition to posting this week's folder, I am now working on all the answer keys for the homework. But everything has been posted of the new material except for the answer keys. Any questions for me?
So after we do our test, that's basically the end of the semester, so then we can determine if we have a final.
That is correct. So after your exam 4, which is the Monday after Thanksgiving, December the 2nd, if I am going to grade like a crazy lady so that I can have your grades finalized by that Thursday, so you can decide if you're going to take the final. So that is that heads up. So yes, if you're happy with your grade, you don't have to see me after that 4th exam, which I will be sad about. But because I've enjoyed this class. But I do understand too. You've got a lot of other classes.
You said the test is Monday, correct?
Yes.
So if we have class on Wednesday and Friday,
If we have, if I can, since we're not having a demo day, it means I'm going to grade all day Tuesday, so you'll be able to determine whether you come to class that Wednesday. Because what that Wednesday will be is a review day for the final.
Are you going to give us our grades like with the drop things, like final grades and like the drop, or the
Okay. So the question is, will I give you your grade with the final, the drops and all of that? So I actually already have that programmed in the Blackboard. You just cannot see the columns. Because the columns will be confusing at this point because they're still points out. That being said, as soon as I grade exam 4, that column will pop up. And there will be 2 columns that pop up. The first column will be with exam 4, basically with the 4 exams, no exam drops. This would be your grade. And the other column is going to be a column with 1 exam grade drop. That column will be the one that you use to calculate what you need to make on the final to get an A, B, or C. And I'll explain that in an announcement when I release those 2 columns. You can come ask me. I know today is the W deadline. If any of you are questioning what you should do, you can come see me. I can at least give you the facts. I'm not going to tell you what you should do, but I can give you some facts as to where you stand. Any other questions for me? I'm trying to be as open and have thought as far ahead as I can. The extra credit will get uploaded. I think the last day to turn in extra credit is next Friday. So I will upload it after that. Any other questions? And I'll be able to upload your attendance about that time too. So over the Thanksgiving break, I'll upload attendance, bonus, and most of your grades will be uploaded by then. Okay, so we're going to get started in today's information. So a while back, I said that the majority of the semester was going to go to answer 3 questions. How fast does a reaction occur? To what extent does the reaction occur? And does the reaction occur the way it is written? We have answered how fast the reaction is going to occur. That was done when we did the kinetics chapter. We have been spending time answering to what extent a reaction occurs. That is all about equilibrium. And the equilibrium constant tells you a lot of information about to what extent a reaction will occur. Now we're going to answer the question, does the reaction actually occur? And there's 2 methods by which we can tell whether a reaction actually occurs. One is Gibbs free energy, and the other is going to be the cell voltage in electrochemistry. Those are going to be our 2 main ways of telling whether a reaction occurs. And what I mean, does a reaction occur? I mean, does it occur in the direction it's written? In other words, will the reactants that are shown in that reaction go to make those products that are shown in that reaction? Will it occur spontaneously? Or will we have to alter the environment to make it occur? Now, yesterday, I introduced 2 equations, and these 2 equations are one way to answer whether the reaction is going to occur, and that is to calculate Gibbs free energy. Gibbs free energy can be calculated as delta G is equal to delta H minus T delta S. Or delta G is equal to a negative RT natural log of K. Now, we're going to talk about these 2 equations for the most part today, Friday, and into Monday. Now, you'll notice a new notation. Yesterday, I just said delta G is equal to delta H minus T delta S. And delta G is equal to negative RT natural log of K. But today, I've added a slightly new notation, and that is the naught. Delta G naught is equal to delta H naught minus T delta S naught, where that naught is indicating that the substances are in their standard states, under standard conditions. Standard conditions are 1 molar for a solution and 1 atmosphere for a gas. And then solids and liquids, they're just solids and liquids. So again, today we're going to discuss both of these. Today we're going to specifically start on the discussion associated with Gibbs free energy calculation using delta H minus T delta S. Now, basically, folks, what it means is that Gibbs free energy is based off of two things. It is based off of the enthalpy, and it is based off of the entropy. Now, it took me a long time to figure out how to keep them straight, enthalpy and entropy, because they are very similar in both spelling and sounds. So one of the things I realized is enthalpy has an H in it, and it's associated with the heat of reaction. So that helped me keep which symbol is enthalpy and which symbol is entropy straight. Now, in college chemistry 1, you went over enthalpy. And enthalpy is spontaneous if you have a negative delta H. It is spontaneous with respect to the heat of the reaction if you obtain a negative delta H. It is going to be non-spontaneous if the enthalpy is a positive value. Now, a negative enthalpy means that the reaction is exothermic. It means that heat is a product of the reaction. What it really indicates is that when we look at a reaction, you have the system and you have your surroundings. Since energy cannot be created nor can it be destroyed, energy will have to enter into the system in order to get the reaction started. Sometimes that energy is just a matter of mixing two things together, and that combination is enough energy to get it started. Now, whatever goes into the system is a positive value. So when we're talking about heat, we're going to put in some heat typically in order to get the reaction started. It may not be anything obvious. It may just be something very, very small, but we're going to put in a little bit of heat to get the reaction going. Once the reaction is going, the system, the reaction, is then going to generate energy. And that energy, if it's in the form of enthalpy, is negative. So when I say heat is a product, what it really means is that more heat was generated as a result of the reaction than was consumed. To get the reaction started. And therefore, that excess heat is listed as a product. Now, if a reaction is non-spontaneous with respect to enthalpy, then it is going to be an endothermic reaction. Which means that the heat, the difference in these two is going to be listed as a reactant. It's listed as a reactant because if it's endothermic, you've got to keep pounding this system with heat in order for the reaction to occur. That's why it's considered to be non-spontaneous, is because without that external environment pounding the reaction, it's not going to occur. Now, you learn to calculate the enthalpy of a reaction. Enthalpy of a reaction is equal to the sum over all products of the number of moles times the delta H of formation minus the sum over the reactants of the number of moles times the delta H of formation. You use this equation in college chemistry 1 to calculate the enthalpy of reaction. Now you'll notice I have delta S and delta G listed because we're going to continue building on that particular table. And we're going to start that now. We're going to start that with entropy. Entropy is represented with an S. Now, entropy describes the change in randomness of the reactants compared to the products. What do I mean by randomness? What I mean by randomness is the degree of disorder. And one of my favorite things to think about is, and one thing about entropy is always moving towards greater disorder unless forced to do otherwise. Entropy always moves towards greater disorder unless forced to do otherwise. Now, I can give you an example that the majority, if not every one of you, has experienced. Let's take a sock drawer. You know, it takes time to organize a sock drawer. Organization requires you to put in energy. But it doesn't take much time for that sock drawer to become disorganized. That's because from an entropy standpoint, the world is constantly moving towards disorder unless you put the effort in or the work in to make it organized. Now, that you got that picture in their mind, let's talk about chemicals. Well, if we're looking for an increase in entropy,
The very first thing, and I always look at this first because it's going to tell the biggest story, is going to be the state of matter. A solid is an organized substance where the molecules, for the most part, are in a very tidy 3D array. Now, if we're going to move towards greater entropy, the next thing in line would be a liquid, because the molecules, they're not nearly as tidy. They're allowed to flow over one another, but they're still fairly close together. They have intermolecular forces that keep them in close contact. From there, we can move to aqueous. Well, aqueous, okay, it's kind of like a liquid, except now you have two different particles involved. So that automatically increases the disorder, the randomness. And then finally, we move to gases. And of all the particles, a gas is going to have the greatest randomness, because those gas molecules are moving in every direction, bouncing off walls, moving in the opposite direction, bouncing off ceilings, moving in another direction, bouncing off of you. It's moving any which way. So from an increase in entropy, we move from solid to gas. That means gas molecules are going to have the greatest entropy. They're going to have the greatest randomness. They're going to have the greatest disorder. Now, if I cannot decide what a reaction is likely to do based off of the state of matter, then I go to the second thing, and that is the amount of molecules. Going back to my sock drawer, it's easy if I only have 2 pairs of socks in it to keep it pretty organized. But if I have 30 pairs of socks in it, it's going to get disorganized pretty easy. So the lower or the fewer molecules the less randomness compared to the more molecules. Now, I'm going to go back to my table. So what are we looking for? A spontaneous reaction with respect to entropy is going to be a positive delta S. It means that the products have a greater disorder Whereas the opposite is true if we get a negative delta S. If we have a negative delta S, it means that the products have a greater order. Yes.
This isn't one where you're like comparing products to reactants. This is one where you're like strictly looking at the products and gauging how much is really enough.
I'm looking at the products and comparing it to the reactants and deciding who has the greater disorder. So let's just look at some examples. Let's start out fairly straightforward. We know that carbon dioxide in solid form, which is dry ice, will go to form carbon dioxide gas. Would this reaction have a positive delta S or a negative delta S? It's a positive delta S because the products have greater disorder. Let's look at this next example. Sb2S3 solid plus 3Fe solid goes to form 2Sb solid plus 3Fes solid. Would this reaction have a positive delta S or a negative delta S? Here, the state of matter doesn't help you because they're all solids. So you have to go, okay, this side has 4 moles of solid, whereas this side has 5 moles of solid. So which would it be? It's a positive delta S because there is greater disorder in the products. Let's look at another example. Let's take one that you should be familiar with from biology. 6 CO2 gas plus 6 water liquid goes to form C6H12O6 solid plus 6 O2 gas. Is it going to be a positive delta S or a negative delta S? It is indeed a negative delta S. It's a negative delta S because we made a solid. Number 1. Number 2, we went from 12 molecules down to 7.
But for me, negative delta S, it's not that the reactants have more disorder, so the products have a better order.
Well, I mean, you could say reactants have the greater disorder. You could say products have the greater order because, I mean, they have to be opposite each other. Now, entropy can be predicted, and that's what we've been doing, is we've been predicting the sign of the entropy. But entropy can also be calculated. And the nice thing about the calculation for entropy is the formula is identical to that of enthalpy. So it's going to be the sum for the products of the number of moles of the substance times its S naught minus the sum over the reactants of the number of moles times its S naught. So let's just take that last reaction that we just did and let's prove. So 6 CO2 gas plus 6 water liquid goes to form C6H12O6 solid plus 6 O2 gas. So the delta S naught of the reaction is going to equal the sum over the products. So basically you can get, the S naughts come from a thermodynamic table. That I'm about to use. You will be provided the table on an exam. So it's going to equal 1 mole of C6H12O6 times its S, which its S is 212, and that's joules per mole Kelvin, plus 6 moles of oxygen times the S of oxygen, which is 205 joules per mole Kelvin, minus the reactants, so 6 moles of CO2 gas times 214 joules per mole Kelvin, plus 6 water liquid times 70 joules per mole Kelvin. I will say, just like with enthalpy, state of matter is important.
Okay. We're ready to do this math. And when you key this into the calculator, you get a value of negative 262 joules per Kelvin. Looking back at our prediction was correct because we said it would have a negative delta S. Yes. The answer to your question is yes, you're going to have to use the calculation, not for comparing the delta S, but because you have to be prepared to calculate the delta S so that you can calculate delta G. Let me give you one to do. Another reason it's nice to have it is because, for instance, in this next reaction, you cannot predict simply by looking at the state of matter or the quantity. So in this particular case, it's important to be able to calculate it because you can't really predict which way it's going to go. So when I look up the S naughts, again, they're going to be in joules per mole Kelvin. For methane, it is 186. For oxygen, again, that's 205. For carbon dioxide gas, that's 214. And for water in the gas form, it is 189. So take a moment and do the calculation and determine whether this reaction is going to be entropy favored or not. When you complete the calculation, you should have gotten -4 joules per Kelvin. So this one is, there's less disorder. In the product. But it's not much less. Questions? Again, yes.
So like, if we want to test and got this problem, if we said the reactants had a greater disorder, would we be
If you say reactants have a greater disorder, that's fine too. They're both correct. Okay, just so that I finish out this table, because we will start with Gibbs free energy on Friday. We will do Gibbs free energy, and then we may start getting into Gibbs free energy. We'll get into the other equation, which was Gibbs free energy is equal to -RT natural log of K. We'll start mixing it all together. But Gibbs free energy, if it is a negative delta G, it is a spontaneous process. It will occur. If it is a positive delta G, it will not occur without external environmental influences. You can have a reaction that is not enthalpy favored, but it's entropy favored. As long as that delta G comes out negative, it is going to occur. That's the entire rest of the story. You gotta know what this is to say, yes, without a doubt, it's a spontaneous process, the way it is written. And with that, we will pick up with calculations of Gibbs free energy on Friday. And then that will allow us to move to non-standard conditions on Monday and start electrochemistry on Monday. You too. Oh, thank you. It doesn't matter. You can turn it in today or Friday. It doesn't matter.
That's like